is what's going to happen here. Yikes, this is a little harder than I thought here. We are looking at a little bit tougher inequalities in this. Let's just start with your basic garden variety one. I think we've done this before. If x is greater than 6, have we done this before? No? Yes?
No.
How do you show x is greater than 6 for an answer? We have to use Lauren, a number line where at the number 6 we put a circle. Okay? Now the circle is either colored in or it is not. What tells you whether it's colored in or not? What tells you that is this little lack of a equal sign down here. If there was a little sign down here that said x was greater than or equal to 6, then you would color that in. If there's no equal sign down there, it's just an open circle, because what it tells you is that it starts at 6 but does not include 6. Because if I asked you, is 6 greater than 6? No, it is not. Okay, but 6.1 would be greater than 6, or anything above 6 is 6. So it starts at 6 but doesn't include 6. And it's any numbers that are bigger than 6, so the arrow goes off in this general direction like this, because on your number line this would be 7, 8, and so on forever this way. You sure we haven't done this before? I find it hard to believe that we would do this and do the next thing that the book wants us to do. Okay, so another example would be this. If it is x is less than or equal to negative 2. It's really easy to do. It's really easy to graph, because all you're going to do is put a line here. You make a negative 2, because that's the number you're talking about. In this case, x can be equal to negative 2, so that means you need to color in the circle. Okay. If it's equal, you color it in. Okay. If not equal, it's open. Okay. And then on what side are the numbers less than negative 2? That would be on this side over here. Okay. And a little check for you on this is, if you look at the little inequality sign, it's the same as the arrow is. This way, greater than kind of symbol there. So your arrow matches up with the inequality there. Jackson?
Pointing.
Okay, and note on every number line, when the numbers go to the left, they're smaller. As you go left, as you go left, the numbers keep getting smaller. As you go right, they keep getting bigger. It's negative 1, 0, 1, 2, and 4, so on and so on.
So yeah. Why would the arrow go back?
Why would the arrow go which way?
Instead of 3.
Because this is the number, x is less than or equal to negative 2. These are where all the numbers that are less than negative 2 are. So it goes this way. Lucas?
So what is like the point of, are we just gonna have to graph down a line?
Yes, you are just graphing these on the line. Except for what I'm going to talk about next. Which means sometimes, ladies and gentlemen, kids of all ages, you're going to have to solve these inequalities. In other words, the book will give you a problem that looks like this. X plus 6 is greater than or equal to 3. In order to be able to graph that, you've got to solve this for x just like a regular equation. Do it the exact same way. Figure out what x is greater than or equal to, and then graph it. So what do I have to get rid of here? The 6. How do I get rid of a plus 6? I subtract 6. If I subtract 6 from 3, I end up with negative 3. Now once you get it to that point, then you can just draw your number line, and again, put a circle at negative 3. Going to be colored in or not, Sage Hyde?
Wait, is that an equal sign?
Is that an equal sign? I believe it is. Yes, it is colored in because it can be equal to that. And looking at the arrow, it goes this way, so it's the numbers greater than negative 3 goes this way. Are you with me on that? Because we're not quite done just yet. Right.
Why do we have to equal sign?
Goes there at the beginning of the problem. Greater than or equal to. Have we not talked about those either? We not done this year? That's bizarre. I guess we should write these down if we haven't done it. We haven't done these?
No.
This is the greater than sign.
Should we put it on the page?
I would put this right here. This is the less than sign. This is the greater than or equal to. This is the less than or equal to. These are your inequality signs. They tell you things that are not, or almost not equal. Let's look at another one. How about this one? 4x is greater than 12. To solve that, Jeremy Schwartz, I need to do what? Divide by 4. And what do I get when I divide 12 by 4? X is greater than 3. And then to graph that, it would simply be what? At 3 an open or a closed circle? Everybody now, open. And which way does the arrow go? To the right or to the left? To the right, because that's where all the numbers that are greater than 3 are. By the way, this is the bare minimum I need to see on your paper. Sometimes people just put an arrow. With no number there, you can't do that. You have to give the starting number. It needs to have a circle there, whether it's open or closed. Okay. Ready for it to get kind of a little bit more complicated? Here, take a look at this one. What strange thing do you notice on this one here? Here's where something really matters here. Lucas?
Number goes first.
Okay. And this one, the number is put first, and that is unacceptable in math when it comes to inequalities. Okay? If it was an equal sign, it doesn't matter what side. Inequalities, it does. Okay? I need to flip-flop these two. But here's what you must understand. Back in the day, when you were talking about inequalities, remember your teacher told you this was the alligator, and the alligator's eating the bigger one, yes? Remember that day? Okay. It still stays true today. And it stays true if you flip-flop them. In other words, this, x is bigger than this. So when you flip-flop them, the alligator understands that, and the alligator still wants to eat the bigger number. Okay? So if you change places, with equal signs, it doesn't matter because everything's equal. If one thing equals one thing, it doesn't matter. If you have two things on a weight, on a scale, and they're equal, you can keep flipping around all you want, the scale's going to stay balanced. Okay? But if you have on a balance, if you have the x being heavier, okay, than this side's going to get weighed down. Well, if you flip-flop places, okay, it doesn't stay like that. The x is still heavier, so it ends up being down, and the other side goes up. Okay, so you have to change the signs when it comes to that. Yes?
Why does it matter?
Huh?
Why does
Because when you graph this, you're going to have to think about it like this. X is bigger than 6, and it's got to go this way. And when you do this, would you think of it that way? Probably not. It's just the acceptable way in math. The letter has to go to the left side when you do inequalities.
What about like if it's the
If it's an equal, then equal sign doesn't matter. The sign still flips, but the equal still stays. Okay? The equal sign still stays. If the equal sign was there, then this would be colored in. I mean, it would just stay right there. It doesn't go away when you flip it, or nor does it come when you flip it. Good, because then we've got the hard problems. Ready? 7 is less than or equal to x minus 8. 7 is less than or equal to x minus 8. Now, hopefully on this you realize two things has to happen. Number one, the x somehow has got to get to the other side, and number two, you got to get the x by itself. I would suggest that you get the x by itself first before you flip-flop everything. Just because I would think that's not a bad deal to do. Get this 8 over here by adding 8. Add 8 over here, I get 15 is less than or equal to x. And then, just like we talked about, go ahead and flip them to opposite sides, but you have to remember that the alligator still knows that x is bigger than 15, and you keep that equal sign there. And then, once you get it to there, you can graph it. Here at 15, and it shoots off this way. Happy? Relatively? Sad? Frightened? Scared? Jackson?
Shouldn't the circle be colored in?
It should be colored in. I was just waiting for somebody to say it. Nobody else knows, Jason. You win the prize.